What I'm going to do here is briefly describe a power cycle. That is a cycle where we use high temperature heat to generate work. And this is essentially the basis of the power plants that generate most of the electricity, whether they're burning coal or natural gas or some petroleum product. The cycle for large-scale commercial processes can have additional complications beyond what I describe here, but the concept's the same. And the idea is that we have some high-temperature source of energy, burning coal, and we use that to evaporate a liquid. So what we're going to feed to this boiler is a high-pressure liquid. The high pressure is important because we want this to boil at high temperature. Efficiency is better if this is at high temperature. So we come in with a liquid, we leave with a superheated vapor. So we've boiled it and we've raised the temperature above the boiling point. So this has a high enthalpy. We then run this superheated vapor through a turbine. And the idea of the turbine is we're going to get work out. We're going to then leave with a lower temperature, a lower pressure, but it's still a vapor. It may have some quality, meaning there's some fraction of liquid droplets entrained in the vapor. But this change in enthalpy is where the work comes from. This is the whole objective, is to get work out. But to complete the cycle, we have to take this vapor and condense it. And what we're doing here is making it a liquid so that we can raise it back to high pressure. So with the liquid, we are at low pressure because we left the turbine at low pressure. We have to remove quite a bit of heat. This low temperature reservoir is something like a river or a lake or a cooling tower where we're removing enough energy to create a liquid. And we want a liquid here because we're going to have to put energy in to raise the pressure back up so we can get something that will boil at high temperature and we can complete the cycle. It's much easier, takes much less energy to pump a liquid to high pressure than to pump a gas. We have a very small volume change. This is a small number, absolute value compared to this, which absolute value we hope is a big number. So we go around the cycle, and some fraction of this high temperature source is converted to work. And we can talk about the efficiency of such a process as the net work. So let's add these two terms, the work from the turbine here and the work. So this is from the pump. The work out is going to be negative. Work in is going to be positive. And we divide this by the heat added. So you can look at this efficiency as the heat added, that's what we have to pay for. And the net work out is what we can sell. So some fraction of this energy, for example, a typical fraction might be 0.4. 40% of our heat, 40% of the energy in the coal, we can convert to net work. So some fraction of the work, of course, from the turbine has to go to operate this pump. But this is the cycle that's used large scale, some variations of it, for essentially all electricity generation. We're boiling a liquid and we're taking advantage of the fact that it does not take much energy to raise the pressure of the liquid to complete the cycle.